Yes, dear children, in previous class we have studied about the geometrical meaning of the zeros of polynomial. In that, we have discussed about the geometrical meaning of the linear polynomial. Okay, today we are going to discuss about the geometrical meaning of the zeros of a quadratic polynomial. Quadratic polynomial. Yes, see here, you take quadratic polynomial. Here, one example it is given. The general form of quadratic polynomial is already well known, that p of x is equals to ax square plus bx plus c. So a be the coefficient of x square and b be the coefficient of x and c be the constant term. Okay, like that you take one example, x square minus 3x minus 4, this is the quadratic polynomial. You take it as y. This y is equals to x square minus 3x minus 4. Yes, this is the what? Quadratic polynomial. Okay na? Yes, I will take some values. Yes, in the table number 2.1 some values are given. Values of x are minus 2, minus 1, 0, 1, 2, 3, 4, 5, and then corresponding to these x values we have that y values are y equals to x square minus 3x minus 4. This is the quadratic polynomial here. In the place of x you have to substitute minus 2 ones. Yes, you have to simplify it, you will get the 6 here. You have to substitute that x is equals to minus 1, you will get 0, and x is equals to 0 you will get minus 4, x is equals to 1 you will get y is equals to minus 6. Like that you have to write that x comma y minus 2 comma 6 minus 1 comma 0 0 comma minus 4, these are the solutions of this quadratic equation. So okay, yes, now we are discussing about the geometrical meaning of the zeros of the quadratic polynomial, isn't it? Okay, yes, you consider this graph. Okay, yes, you have to locate these points, that minus 2 comma 6 minus 1 comma 0 5 comma 6 4 comma 0 and 3 comma minus 4 0 comma minus 4 and 2 comma minus 6 1 comma minus 6. These are the what? Our points. Okay, yes, with the help of these points you have to draw the curve. Okay, you have to draw the curve. That curve, it is cutting x-axis at this point and then this point. Okay, when that x-axis, when that curve it cuts the x-axis, that intersecting point itself, it is considered as a zero of this polynomial. Okay, yes, this is x dash axis and this one it is x axis. Totally it is called it as what? X axis, isn't it? Okay, yes, this curve it is cutting at this point, it is intersecting at this point here. That point it is minus 1 comma 0. Minus 1 comma 0 be the zero of this quadratic polynomial y equal to x square minus 3x minus 4. And then one more point is there. This curve it is intersecting at this point here. This point it is 4 comma 0. This is also our required zero of this quadratic polynomial y equals to x square minus 3x minus 4. Okay, yes. And then here it is given here that y equals to ax square plus bx plus c. This is what? Our quadratic polynomial general form. Okay, when that curve it intersects the x-axis, that intersecting points are the zeros of the polynomial. Okay na? Yes, this is about the what? Quadratic polynomial. And next one it is cubic polynomial. Cubic polynomial. Before that cubic polynomial, you take these structures. Yes, see here, one curve it is given. In case number 1, that is 2.3 structure it is. Yes, first structure, what it says, this curve it is intersecting in 2 points on the x-axis, isn't it? Okay, one it is a point and another it is the a dash point. It means this is having 2 points, this is having two zeros in the sense that is quadratic polynomial. Okay, and next here you have to consider second structure. This curve it is cutting at 2 points, a dash and a. It means what? This is having two zeros. It means what? This is also curve of quadratic polynomial. Okay, case 2 you have to consider here. See here, that quadratic polynomial in the sense that is having two zeros. Okay na? Yes, these two zeros, these 2 points are coincide with each other at this point a. Okay, this is having two zeros, but that two zeros are coincident at the point a. It means what? This is considered as only one point, that is a, isn't it? Okay, it means what? That quadratic polynomial it is having a one common point. Okay na? And next you have to consider this case number 2 here. Okay, yes, this point it is having this point, that curve it is on the x-axis, it is intersecting at one point here, that is a. It is also having only 1 0. It means what, it is having two zeros, but these two zeros are coincident at point a. Okay, okay, see here, one it is given here, the x coordinate of a is only 0 of the quadratic polynomial ax square plus bx plus c in this case, right? Okay, and case number 3 you have to consider. Here the graph is there, is either completely above the x-axis or completely below the x-axis, so it does not cut the x-axis at any point. It means what, this is not having any zero of the polynomial, this is not having any zero of the polynomial. This is above the x-axis, and this curve it is below the x-axis. It means what, this curve it is not intersecting with the x-axis, and this curve also not intersecting with the x-axis. It means what, this quadratic polynomial it is not having any zeros, right? Okay, that it is given here. So the quadratic polynomial ax square plus bx plus c has no zero in this case. Which case? In the third case, this is not having any zeros. Okay, yes, up to here we have discussed about the quadratic polynomial. Now I will discuss about that cubic polynomial. Already well known, that is p of x is equals to, yes, you take x cube minus 4x. This is what, cubic polynomial. The highest degree of the highest power of the variable is 3, that is called it as what, cubic polynomial. Okay, yes, you consider this y is equals to x cube minus 4x. Okay, this is what, cubic polynomial. And then I will take some x values. It is given here in the table 2.2. X is equals to minus 2, minus 1, 0, 1, 2, and corresponding these x values we got here y values. Y in the sense, that is what, p of x here. Okay, that p of x or y is equals to x cube minus 4x. So 0, 3, you have to substitute in the place of x minus 2, minus 1, 0, 1, 2. Yes, we will get that 0, 3, 0, minus 3 and 0. These are the y values, these are the x values. You take that points in the form of x comma y, minus 2 comma 0, minus 1 comma 3, 0 comma 0, 1 comma minus 3 and 2 comma 0, like this you have to take it. And then you have to locate all the points in the word graph sheet here. Okay, this is the what, minus 1 comma 3, and this is 2.2 comma 0, and this is minus 2 comma 0, this is 1 comma minus 3. You have to join all the what points with the help of that curved line. Okay, yes, you will get one structure here. Okay na, yes, and this is minus 2 and 0 and 2 zeros. Cubic polynomial it is having 3 zeros. It means what, that zeros are the factors in the sense, those are the roots of that given polynomial. Yes, if the linear equation, if it is said to be linear equation, it is having only one root or 1 0, and if it is said to be quadratic equation, it is having two roots or 2 zeros, and if it is said to be that cubic polynomial, that is having what, 3 zeros and then 3 roots. Okay, roots and zeros, these are the same. Okay na, yes, and then this is having how many zeros here? Yes, this is 0 comma 0, and this is minus 2 comma 0, and this is 2 comma 0. This is minus 2 comma 0, and this is 2 comma 0. These two are the zeros, and this one is also origin. Yes, it means what, this curve it is passing through the origin here. Therefore this point you have to consider 0 comma 0. So this is cubic polynomial, no? Therefore it is having 3 zeros, like this. And then here you have to consider here x cube minus x square. You have to draw the graph of this x cube minus x square. You will get like this. These are the points, 2 comma 8, 1 comma 1, and then minus 1 comma 1, minus 2 comma 8. These are the points here. Okay, this is having one point here and one point here, and this is passing through the what, origin here. Okay, that is what, 0 comma 0, and this is also same here. Okay, yes, like this. These are the what, some examples here. Okay, yes, you have to consider example number 1. Look at the graphs in the figure 2.9 given below. Each is the graph of y is equals to p of x, where p of x is a polynomial. For each of these graphs, find the number of zeros. See here, you have to consider this one. This curve it is intersecting at this point on the x-axis. It is having only 1 0, and then this curve you have to consider in the second structure. this curve it is passing through the 2 points on the x-axis here. This is one point and this one it is a second point. It means what? This is having two zeros. It is quadratic polynomial and this one it is linear polynomial. Yes, you have to consider this third structure. First point, yes, this curve it is intersecting with this point on the x-axis, and this is the second point on the x-axis, and this is third point on the x-axis. It means what? This curve it is intersecting at 3 points on the x-axis. Therefore this is having 3 zeros of the polynomial. Okay, and then here you have to consider this is the straight line. No, straight line in the sense that is linear polynomial. Linear polynomial in the sense that is having only 1 0. It means what? If you have to consider this one, this line it is passing through this point. This point it is on the x-axis here. It means what? This line it is intersecting at the x-axis only on one point here. Therefore this is having only 1 0. And then here you have to consider it is also having only one point. Okay, 1 0, because if it is having 2 points, it means what? That 2 points are coincident at only one point here. Therefore this is called as what? Only 1 0. And then here you have to consider, yes, this curved line it is intersecting with this point. This is first point, this is second point, this is third point, and this one it is the fourth point. It means what? This curved line it is intersecting at 4 points on the x-axis. Therefore this polynomial it is having 4 zeros. 4 zeros in the sense this is the what? Biquadratic polynomial. This is what? Cubic polynomial. This is what? Quadratic polynomial. This one it is what? Linear polynomial. Okay, yes, their solutions it is given here. Once you have to see your book here, right? And then exercise 2.1 it is given. Exercise number 2.1. Yes, what is that question? The graphs of y equals to p of x are given in figure 2.10 below. For some polynomials p of x, find the number of zeros of p of x in each case, right? Okay, this is not intersecting with the x-axis. Therefore it is not having any zeros. It means what? It has no zeros, right? And then this curved line you have to consider here. It is intersecting at only one point on the x-axis. Therefore this is linear polynomial. It is having only 1 0. And then you have to consider this third one, 1 2 3. Yes, it means what? This curved line it is intersecting at 3 points on the x-axis. Therefore you have to consider this one. It is what? Cubic polynomial. It is having 3 zeros. And then here you have to consider this is having 2 zeros, 1 point and second point, and 1 2 3 4. This is having 4 zeros, 1 2 3 1 2 3. It is having 3 zeros like this. Okay, this is about the exercise point 2.1 here. Okay, in the next class we will discuss about relationship between zeros and coefficients of polynomial. Okay, yes, you also refer your textbook. These examples and the structures are given. Yes, I didn't explained about with the help of that drawing and that how to draw the what pictures and all, because it takes more time to draw the graph here. Okay, yes, I have given this book diagrams only in this explanation. Okay, yes, you also refer your textbooks, and you have to write and you have to draw in the pair book. Okay na? Thank you.